Last lecture, we talk, just a minute. We speak about software-defined networks. Main concept is how to divide control plan out of control plan from one side, as usually. From one side, just a minute. So, software-defined networks, it is concept of division control plan and data transmission infrastructure for scalability, for control of quality, and so on and so on. What is the main contributions and main issues in software-defined network? First of all, it's open flow protocol is used for is used for delivering information from nodes to controller and also and back. Main idea is moves the control plan out of devices and made it programmable, and concept of logical centralized control via single entry. So SDN controller controls the same number or some nodes and provide uh, control or renew. It's make overload of routing tables, take some statistic of some monitoring of the node and so on. Also, data plan control evolution requires some changes of standards. As you know, telecom Telecom, as always, works with standards because too many people, too many devices, too many technologies, too many some other things, and all of them should work together as one, as a whole system, independent on who provides this or that service or this or this that equipment and so on. Therefore, always when we talk about telecom, we talk about some standards. Everything should be should work with the same standard. Therefore, for providing software-defined network, we need new standards, and also some people make it. So computer wants to me to speak fast about software-defined networks and go forward. Okay. There is no limits on interoperability between vendors. So different vendors can provide different applications, and these applications can be used by controller and so on. It's not me, it's computer. It wants to go forward. So conclusion is that is then is flexible. Uh, you can provide effective management and so on. Last week I sent that book about 6G and how it was, why we talk about this, because This concept of software-defined networks, and next our topic is network functional virtualization. It's spreadly used in new technologies. Maybe it's not some single technology. Some elements of this concept is integrated with new generation networks. In new generation of mobile networks and so on. Because, as you know, all networks, all telecom systems, they need flexibility and they need scalability, because we always have to provide more and more different services, and these services is make some load to telecom networks. Therefore, we can speak about we can understand this concept, and also we should understand how to integrate this concept into into telecom networks. Next question or next topic of our lecture is network function virtualization. What does it mean? Why it is? What does how it? What is difference between software-defined networks and network function virtualization? Actually, it's also concept, and this concept say not as software as they did talk about division of transmission, data transmission and control plan into two layers. In software-defined network, we don't speak how it will be organized, but we speak about some function, because each telecom node, each device, each channel, and so on has its function, and some function can be some functions some functions are hardware used can be can be organized only with some equipment, and some functions can, no, it's programmable, can be programmable, and when we understand which function of the devices, or for example, a function of base station, or of some node, how to manage this or that. So some some functions. So we can calculate it, or we can process it somewhere in cloud, or somewhere as application on of for SDN controller. So it is different, because software-defined networks talks about how to organize this division. Then software NFV talks about functionality of telecom equipment. So some basic terms. Software network function is functional block with network infrastructure that has well-defined external interfaces and well-defined functional behavior. So we can understand what this function do, and what is its interface to communicate with other devices, or where it is implemented, and how it works in the whole picture of telecom. In practical terms, network function today often is network node or physical appliance. So network function virtualization is the principle of separating network function from hardware and run them into virtual hardware abstraction. It means that software NFV propose to make some двойник, я don't know how it's in English, some issue which is double that function and making them in some way in cloud. Network function virtualization infrastructure. It is a very interesting thing because we need not only telecom function. It's as usual. It's should be very fast. So we can't send by mail somewhere that question, and then after 3 days receive the response. It's not. It doesn't work with telecom. In telecom, we have real-time services, and we have to receive real-time answers. So we actually it's the main question of our lecturing because we talk about high-loaded systems and resources for them, planning infrastructure. Exactly, infrastructure for NFV, it is the infrastructure for high-loaded system because all functions in telecom they used they are used very often. Very often, each service, each flow, each subscriber want to make something, and it's the same functions, same services, and therefore it's high-loaded system and infrastructure who can serve all that number of requests. For sure, it's a huge problem. It's a huge system. According to NFV resources, it is about actually it's as network function virtualization. It's some virtualized issues. Then resources, it is some computational resources. So some memory, some channels, some processing time, and so on. So it is some virtual. It is some computational resources somewhere in virtual infrastructure. So, but actually, we work not with something ununderstandable. Virtual resources, it's also some physical resources, but they are not here, but somewhere in virtual machines, somewhere in cloud. Therefore, NFV, it is NFV resources, it's computational resources somewhere, but we need to calculate them, to plan them, and so on. So main principle of NFV, it's so we have some telecom node and telecom network with nodes, and this node have each have its virtual node somewhere in data center, and that virtual node communicate with telecom node with some open flow algorithms. So it means that for sure we can't move some function of node connected with data transmission. We don't don't move it in the node. We move only some control plan, control tasks. So no data in data center, no data flows in the data center, but all connected with data flow management, filtering, some different things. It is works with virtual node. So it's the main principle. So divide some functions which can be done in cloud and send it there. There is some examples how it works. How it works. Actually, what we have, what we can see on the picture. On the picture, we can see the network. This network is some company or some no, or group of companies who integrated into one local networks. What we can see branches of these networks from these branches, for example, one office, one subsystem, and we have to organize the network between these branches and between some virtual CPE. So why we need virtual CPE? Yes, customer primaries equipment. Why we need these virtual things for what? For what? Actually, we can. So we want to organize a network. We want to connect branches into one one things, and for scaling the function of the this virtual CPE, we can use CPE customer primaries equipment. So it's краевой краевые пристрой. So we have some transport network, some tunnels between them, which is organized with different technology. But anyway, even organized, even using different technology, we want to scale the possibilities of this customer primaries equipment. So equipment which is placed on the border of the network, transport network, and to filtering something, to make to find best to filtering, to find best path, or to different function connected with different function has this this node has different function, and so also we can virtualize it. So what else? Just a minute. So we some explanation of this. Also, we can how it can work. On one side, we can work with, so we can our local network, which how to say, which which is distributed, and somewhere we can see non-virtualized elements, and the same we can see virtual nodes. How it works? Works. We can, according to virtual branch, we can see some switch for Wi-Fi and some few port. So they have some things and other function as QoS, VPN, voice VOC. So different functions, and maybe more function than we can understand now. We can this function can be organized somewhere in virtual CPE. So what does mean virtual CPE? It means that you remember this picture. It means that somewhere in data center, this function is processed and it works with these functions. So if we don't have um, virtual CPE, we can put different physical devices, all of them, some forwarding, some are I don't remember what does mean. Some other functions. So what we can see with virtual branch. Some function is stay in the devices because it's connected with data transmission. Some functions is divided. When you speak about non-virtualized branch, we should work with physical devices which has its limited resources and we can change rules of its fast changing of the rules of its how it works. According to virtualization, how it so we when we so different different branches of the local network can be organized in the common network with this virtual CPE. So so as I told you, NFV it's when we some functions process somewhere in the cloud. It's the main idea of this virtualization. According to function, what function? What does it mean? Integrate into signal virtual machine. Implement the equipment of functionality and single physical PE and subset of physical piece of capability. Okay, so you can read this without me. So main idea to divide some function which can be made by some function which can be made by computational resources should be divided and so on. According to it's explanation of what does mean that short names of the on the pictures. It's access router, threshold router PE, forward firewall, and so on. So function is deployed today on the networks without virtualization. Function was deployed as centralized hardware infrastructure in future, or when it's um, ideas will be uh, improve, no, not improve, when NFV will be in each device in our networks. The service provider may provide virtual network, VNF, virtual network function as a service for enterprises for corporate. So what we receive, so you can see that somewhere when we need this device, when we see on the network without virtualization, we need for each one, we need some physical devices. And these physical devices will work only as we, according to its, how to say, in its functionality. When we work with network function virtualization, or we can make it with hours, or we can, as usually, actually, companies of providers of telecom equipment, they propose some solution, and their solution is better than even small companies can provide. So they provide some functionality which is processed in cloud, and then this functionality is more renewable from one side, programmable from other side, and make more scalable, more flexible that network. According to main functions of the networks, and what some of them can be, some of them can be virtualize something not, but base function of the network, it's statistic, network optimization, node connection or disconnection, network reorganization, and network forecasting. All of these branches has its exactly tasks. For example, external monitoring of the node status, internal monitoring of the node status, dynamic load estimation method. When we talk about network optimization, it's dynamic method of network nodes loading balancing, the method of data clustering, and algorithm for optimal routing. According to node connection, it is adaptively power of network nodes to provide localized capacity when needed from according to user demand. So it's node connection or disconnection, because we can manage loading, or we can manage the capacities of the network using input or turn off the nodes. Also, network reorganization, we have to reconfigure networks using most energy efficiency strategy. And so in this case, when we talk about energy efficiency and some instruments for monitoring, it's always connected with some not programmable things. So it's not about physical data transmission. It's some analysis of the network to no, to provide better solution, better network organization for energy efficiency, for fast and so fast transmission, so power consumption while maximizing of throughput of existing flows. Also, according to forecasting, methodology of short-term traffic forecasting model. What does mean forecasting? It means that we have to plan something. How we have to understand how many resources or how many nodes or how many what size of the traffic will be in next few minutes. Why in few minutes? Because during these few minutes we can поднять, we can reorganize our network to make to guarantee some parameters of quality. Therefore, we always have to predict loading, predict traffic, predict our is it will be enough number of resources for next period of time or not. So therefore, this methods is used very often. Logic regression model. So it's also connected with forecasting. It's different models of forecasting. Feature of development virtual CPE and virtual PE. So it is estimated that a large number of virtual devices will need support from a threshold router, which requests a huge amount of resources of NFV infrastructure. So we want from virtual PE self scale on the data plan and control plan to support large redirections, tables, and large number of thresholds. So we need we have to plan this virtual infrastructure, have to predict how many resources we will need, and all this will be done for some guarantees, for some things connected with some guaranteed quality of service, something like this. To achieve goals, virtual functions router must integrate into single virtual machine, then divide into basic of set of function and virtual network services. So no, it's for sure this processes is planned because we can't make some function virtual, then some non-virtual, virtual, non-virtual. So we plan this our network. We know what function can be virtualized, what function can't, and then we talk go with these things. Virtual P is scaling achieved by modification of infrastructure resources allocated to virtual P infrastructure, some memory increase, some maybe better usage of processor time, and so on. Create additional instances for of VP. Actually, when we have divided function from the nodes, we can do with that virtual function what we need, what we want. And for more flexible organization of these functions, it is good to use some microservers elements, some technologies for why microservices good things, because we can produce lots of allocate create additional instances. So we can create as many instances as we need, and all of them will solve the same problem to make our task better. What are the important tasks? In virtualized environment, the responsibility of proper execution of each scenario lies with the virtual and when lies on virtual provider. So we know what we need to organize to virtualize, and provider knows how to organize infrastructure. Also, virtual CPE and PE are needed to support large number of applications, software components, and services, as I told you. Different network technology and configuration may be involved into transition from regular of virtual networks. NFV have to be managed. So we have to for processing, we have to have possibility to manage the NFV processing. So also we should to think and provide some tasks connected with secure connection, some so what it means centralized controller. So we need some to follow some principles and standards of SDN architecture. But as I told you, SDN architecture, no, so actually it's often in literature you can see some questions. NFV, SDN, it's very connected to things because it's how to say, it's different, but different principles, but solve the same problem. Also, so we have to provide complete isolation for users. According to when we look through that model of the local access network to local network of some enterprise. So we have to understand that different networks, local networks, should be independent, and we shouldn't send information from one local network to another. Also, it's these operations requires VPN connection between enterprise and operator virtual function, special measures and protect corporate data. So some security things. But providing NFV as a service, it's quite interesting things, and for as you see, it gives us a possibility to scale our function of the nodes. So it's very interesting proposition. Do you have question according to NFV? What does it mean and so on?
No questions.
Okay, if you have, please ask. According to NFV and cloud computing, what we as as we talk, NFV it is its principle with division sum function out of division sum function of the network devices. But it is very interesting thing that we have to plan this, we have to plan, or we have to book some nodes or some in physical infrastructure. We can manage this with using some data center. Why we speak about this? Because okay, we divide some functions out of the physical node, but where it should be done, where it should be processed. It is necessary to be this process should be processed very fast, and therefore depends on the data. It depends on how we choose data center or how we choose technology to computational resources. Lots of will be depends actually. And here you can see the picture where some group of data center for sure, because when we have requirements to the fast or to the speed of the processing request, we should choose, or we should provide the infrastructure as closer to that nodes as we can for better processing. According to scheme of resources usage is big mathematical problem, big or not, it's very anyway, it should be solved because it's when you talk about effectiveness, each small elements can influence in total effectiveness. So therefore, we ask, sorry, we ask mathematics. No, so we ask mathematics or call mathematics for calculation. The best instruction, it's no, maybe not we, but infrastructure providers, they should plan the resources, plan all that things for better, for finding the best solution, because all delays, it's delays for our services, telecom services, and these telecom services, it's very requirement. All telecom services has high requirements to the speed of processing. According to terms, I think we should. We talk about this, but it's some more definitions or more things. Why connected with cloud? Because we talk about data centers and NFV. So when one of the element of infrastructure, it's It's some components. So what kind of components? It's hardware resources that not that can't be replaced, but they can use for placement there some virtual issues, and so when we actually at the beginning when we uh, mm, why at the beginning I mean that um, at the beginning of cloud services and I think it's about 5 years ago or more. When we talk about com, we want to have some uh, unlimited resources. So we have no delay. Some actually some kind of unlimited unlimited is now we have for example we uh, can use some cloud for how to say uh, for illusion of unlimited resources. But actually, these components, infrastructure components, it's physical cluster, no, physical computational resources, some clusters, some elements, some physical elements. According to virtual machine, I think you know what does it mean. But a virtual machine it used for some it we can because for me for processing that for network function uh, we want to how it works. We place this virtual function into virtual machine and virtual for scaling that resources we can move it from one side to another. So we will talk about this during this maybe later, not today. But anyway, so virtual machine is a node when can be processed physical virtual functions. Virtual networks, also that virtual machines can be organized into the virtual network, and this virtual networks of that virtual network of the routers, information among the network interfaces. So it's no, you can see this description, but for processing a huge number of the requests from telecom network, which process that network functions, we need some infrastructure. Virtual network is one of the element of that infrastructure. According to virtual application, it's exactly virtual functions, some function of the node which is provided as application. Here you can see also very interesting things, but it's, you know, no, one of the idea of this lecturing, it's to how to, it's different views of the same problem. So from one side, we have some node, its function. This function can be placed somewhere in virtual machine. This virtual machine can be organized into a virtual network. This virtual network somewhere placed in real hardware and so on. From other side, it creates some problems for interconnection of the cloud, how to organize all these things for, as I said, for very fast processing, because we want to have fast services. And this picture shows that we have some, no, not more than one public cloud, and we can see here that some virtual machine can be virtual instances can be placed on this virtual cloud, no, some cloud, and uh, runtime application. Also, it should be we have servers of the application. So it's very complicated question. So how that application somewhere in the cloud works. But um, mm, it's actually it's should be organized somewhere. And when we use NFV as infrastructure, so because as a service, so we can somewhere somebody not somewhere provides these processes. For sure, it's not. No, maybe you will not do this with your hands, and it's very huge system, but you should understand how it works. So we have different multi-cloud applications. So one application can work in the different clouds, and for customers, it thinks that it's the same. No, so for end users, these services is not, we can't understand how it works. But maybe that application what we use is distributed into different clouds and so on. For example, Facebook or some social networks. It's one of the examples. So it's very huge application, and for sure, this very huge application should be played. No, for sure, it's placed somewhere in different servers, different server servers and servers, and so on. Same here. It's how it works. So we should interconnect some intercloud interfaces, business to business from one side, from other side. We should interconnection between applications. So it's different questions, but it's very it is necessary to understand how it works in general. Yes, it's telecom hybrid services, telecommunication hybrid service. It's some idea where connect where the service for end user, when we not include, when we think that this services is provided not only telecom network, and also it provided by computational resource. So this, why we speak about this? Because quality of service for end users, it is so provider should be some SLA service level agreement should be provided. So we have to make something quite good, or we should understand how it works to make the good service. Therefore, this idea of this TCA hybrid service is about what from what parts that service is organized. And from this point of view, we can see this picture when some user use different services. From one side, this user communicate with some cloud service, some access level, service level, resource level, some cloud system from one side. From other side, it's quality of service for this. It depends on telecom operation management, and so it's as I told you today, it's different point of view. So we have interconnection between some BSS OSS system of in the cloud who process the request of the end users from one side. From other side, we have some telecom networks which organize connection between that clouds and so it provides telecom communication services and networks, managed telecom services and networks, cloud environment telecom management. So it provides some services to make that intercloud connection stable. So users think that he works only with cloud services, but actually its service depends on also telecom network telecom provider the work of telecom provider who used this. Actually, we can remind that joke that I'm the best said computer, I'm the best said phone, and haha said electricity. The same situation. So we have adds here that cloud services, telecom services, and also electricity service. So thank God we live. So lots of things can be connected, lots of connected things with quality of service, with this high-loaded system, because we look at this in this system, telecom system, as a producer of high load for infrastructure for no make for process. We have to understand how to process these requests and how to organize this infrastructure. So it's very huge number of questions. So I think it's time to stop because it's 85, 80, 89 minutes. Do you have question to me?
No.
No.
Okay, maybe some people from ETS can hear these lectures in previous semester, but okay, if you have question, you can ask. Thank you. See you next Tuesday. Hope take care of you. Bye bye.
Yes.
Thank
Thank you
you.
too.
Bye.
Bye.
Okay, goodbye.
Bye bye.